Welcome back to the deep dive. We're jumping into part 2 on deep learning today.
That's right. We've got some interesting visuals and descriptions lined up.
Yeah, looking at how it uses these nested feature hierarchies.
Uh-huh.
And our mission really is to figure out why its way of finding features and sorting stuff works so well.
Especially for that tricky, unstructured data, like
Well,
images, raw text, stuff that isn't neatly in tables.
exactly. So maybe start with the old way, traditional machine learning.
Sure. So traditionally, it's pretty separate steps. You get your input data,
Right.
then you, the human, have to figure out the important features, feature extraction.
Like measuring beak length on a bird photo, maybe?
Precisely. You do that manually. Then a separate step, classification, based only on those features you picked.
Okay. Input features, classify output.
Got it. So how's deep learning shake things up?
Well, the big thing, and you can sort of see this in the diagrams we looked at, is that it combines things.
Combines. Which parts? The feature extraction and the classification. They're sort of fused together into one single model architecture.
Ah, okay, so it's not step 1, step 2 anymore.
Not really. When the data goes in, the model itself, through its layers, figures out the features. It builds them up hierarchically.
Hierarchically,
Meaning simple features first, then combining them into more complex ones, layer by layer.
Okay.
And then the final layer uses those internally built features to do the classification or prediction.
So it spits up probabilities. Like 80% chance it's a cat, 10% dog.
Exactly like that. The highest probability wins. And the key is, it discovers features we might not even think of.
Which brings up the question, why bother with all those layers? Why not just map the input image straight to cat?
Yeah, well, that's the one mapping too complex idea, isn't it? It's too big a jump.
For the machine to handle in one go.
Precisely. Especially with messy, unstructured data, the relationship between raw pixels and a high-level concept like cat is incredibly complex.
That's so deep learning breaks it down.
Right. Into smaller, achievable steps, incrementally. Each layer tackles a slightly less complex part of the problem.
Making the whole input to output mapping more feasible.
Exactly, more achievable. You see that progression? Low-level stuff like edges, then maybe textures or corners, then parts like eyes or wheels, then whole objects.
So that's the nested hierarchy of concepts idea we talked about.
That's the core of it, yeah. Simple concepts build into more abstract ones.
Like mathematical functions within functions.
Sort of, yes. Each layer transforms the output of the previous one. Deeper layers learn features that are more abstract, more complex.
Makes sense, like that facial recognition example.
Perfect example. Early layers might just find lines, curves.
Basic shapes.
Then later layers combine those into maybe an eye shape or a nose shape.
Okay.
And then even deeper layers look at the arrangement of eyes, nose, mouth, building up to recognizing a specific face.
And the point is, it learns all this itself. No one told it, look for eyes here.
Exactly. That's the power. It bypasses a lot of that manual, often domain-specific feature engineering work.
And the hidden layers are where this happens. The ones between input and output.
That's right. They aren't directly visible from the outside, hence hidden, but they're crucial.
Doing all that incremental feature learning.
Yeah. Each hidden layer refines the features, adds complexity, contributing to that final, powerful function that maps the input to the output.
Okay, so let's quickly recap the key differences then.
Sure. First, deep learning integrates feature extraction and classification. They happen together.
Right, not separate steps.
Second, this whole layered hierarchical approach is really needed to handle the complexity of unstructured data.
Because the direct mapping is too hard.
And third, it learns this nested hierarchy of features automatically in those hidden layers.
Meaning less manual feature engineering for us humans.
Correct, which is a huge advantage, especially as data gets bigger and more complex.
It really shifts how we approach these problems. Fascinating stuff.
It is.
Okay, so as you're processing all this, here's a thought to leave you with. This way, deep learning builds understanding, layer by layer, from simple inputs to complex concepts. How much might that mirror the way we humans make sense of the world?
From basic sensory input up to abstract thought.
Yeah. Does it learn like us? Or is it something totally different, something to ponder?
Definitely food for thought.
Thanks for diving deep with us again.